Hi, welcome to this AI and C# video on the Microsoft Agent Framework. Today we're going to look at custom chat message stores. So we can have an agent have a conversation, then the user goes away and comes back, and we can resume that. And we have actually done something similar to this in the sample called conversation threads. This is one of the early videos, and we went in and did a resume of a thread by going in and deserializing the thread, where we read all information we wrote to a temp folder. And the same way we stored everything every time we went through a chat loop. So we did it like this. And while this works, it's a bit cumbersome because we need to put extra code in here, we need to put extra code in front, and so on. So wouldn't it be nice if the agent that we create here, which is by default a in-memory agent, automatically did this, and the only thing we needed to do was to get an ID of it. That is what this sample is. So let's set a breakpoint, and I've set a few breakpoints down in something called my message store, which we will understand when we go through the code. So I am in the wrong project. Let me switch to this one here. So close this one. So what we do is we make our normal configuration as always, and we make a OpenAI chat client. Nothing special to do with the agent itself, but what we do down here is that in the chat client options, we set the chat message store factory. And we set it to this my store factory. So my store factory is something that inherits from chat message store. And what it does is it have a thread ID and a path. And in my case, I'm just saving it down to the temp folder. But in real life, you'll probably save it to a SQL database or a blob storage or something like that. But we keep it local, so it's easy to run here. And the thread will either be just a new grid, or when this message store is created, if it gives a serialized state, meaning the ID, it will use that instead. Then it keeps track of the messages while it's running. But when it needs to get the messages, it will try and get it from the file. And if there's no file, we just return 0 because we have no message to rehydrate. Else we get all the data from this file, which is just JSON, and we deserialize it to a chat message. So that is how we get the messages. On the fly, add message will be called. We don't really do it because every time we just make a run async or run streaming async or so, it will automatically call add message. And that's the cool part compared to what we did here, where we always needed to remember to do it after the fact that we had run. So we just need to simply add the messages and write all the messages down into the thread path in here. And then we need to do a simple serialization, and we do that on the thread ID because that's the only thing we need, because the rest will just be stored in the database or the file in this case, and referenced by this. In a database, it would be the ID of the records that have the chat messages. So that is how we have the things, and we just give it into the agent. And then when we say get new thread, we will hit this, and our context here, the serialized state, will be undefined, meaning it's a new one, and for that reason we end up using the GUID.new GUID instead. So this is just the GUID just generated here. And we hit now that we have our new thread. And you can see the store is my store here. So I have my data directly on the system. But that's only because it's a my store. This thread object will not have it by itself. It's so we needed to convert it to a message store like this if we wanted to. But in any case, we can now ask a question, who is Barack Obama, with our thread. And the second we do that, it will go in and check, do we already have messages, so those could be loaded into the conversation. In our case, we don't have any, so we don't need to do anything here. We will then ask the LLM as normal, and the LLM is now done. It's in fact made its message back with that Barack Obama is the American politician, but before the user actually gets it back, it tells call this add message async directly on our store, so we can save it before the user gets it back. So we can save it, and in this case, we're just saving it down to the file. And the user gets its response back. And now we have the option to serialize the thread. And if we do that, we hit our thread ID and get it back as a thread element. And this thread element is only the ID now. The rest is stored in the file. So we could, for example, save this in local storage of a database, or if it was a very secretive program, we could tell the user, here's your ID. If you ever want to talk about this topic again, you need to provide it. So there would be no way for anyone to get it unless they have it. So that could be a security thing. In any case, we get the ID and could tell it to user, save it somewhere. In our case, we just simulate that some times pass. This conversation has been long gone. The user asks for Barack Obama, but they still have this secret key stored somewhere, and they now come back and give us that key. So we have the same object as this, just based on this ID. And for that reason, we can then deserialize the thread. And if we do that, we again hit our message store. And in this case, the serialized state is our ID. So for that reason, we can now rehydrate the thread ID, which then gets the thread path. And whenever we hit this and ask our follow-up question, how tall is he, with the restored thread, we will again hit get messages, but now we know we already have information about that thread. We can read it up in JSON, which was the first question and the first answer. And we can deserialize it and get it back. So on the fly, we give those extra messages to the user. And now it comes back telling how tall he is, and we will save that down into the thread again. So we now got back that he is 6'1", and that would not have happened, of course, if had we not had the restored thread. And that way, no matter how long that goes between these, we will be able to rehide the thread, and the ID of the thread and the real thread is now separated from each other. So we can keep it secret, keep it simple, whatever we want. And also the good thing is, of course, now we have built this. This could be used across multiple agents in a very easy manner. We just need to tell that it has this message store, and that's it. And then have our threads civilized back and forth. We don't need to care about that to have the entire system. All we need is to store the IDs in various different places, wasting less time on the local storage, for example, or having the secret way of working. And that's all there is to it. See you in the next one.